All right. Cool. So ideally, you don't want to install VS Code now because we're going to be doing all of our work in VS Code. I want to say all of our work, what we're going to be looking at for the most part. So I asked you about programming. It is largely a Python course. I don't know if you've heard of the Python programming language before. Yeah. So it is largely a Python course. Most of the work that we're going to be doing is Python. Most of the new work we're going to be doing is Python. The other stuff that we're going to be doing is Arduino. And I imagine everybody's supposed to be familiar with Arduino, writing Arduino code now. If you're not, it's fine. We can go through some stuff, but I'm not going to be really teaching you Arduino. I'll be showing you the concepts used to use Arduino code in the context of IoT, but I'm not going to be focusing too much on teaching it, like getting integrity and all them something. But yeah, I will be doing a crash course on Python, because even though yes, it's a Python course, it's not an introduction to Python course. It's a case where I would hope that you'd have some programming knowledge before, and you take that knowledge and you'll be able to transpose it onto this new programming language that we're going to be using. Yeah? So I'm going to be going through a few stuff to show you, and if you can basically relay the information I'm giving you onto what you already know, you should be good. Yeah? Python is not a difficult language to learn, in my opinion. It is very different from C, though. It looks different, it feels different, it doesn't have any curly braces, and it takes indentation extremely seriously. Meaning if you indent wrong, the code not going to work the way you expect it to. Yeah? But you know, like in C, it don't matter how you indent as long as if you open and close curly braces. Yeah, we don't have curly braces in this. There are curly braces, but we don't use them in the same way, as in like the C-like languages. Loops, for loops feel different. So you know, like in C languages, you have for I equals 0, I less than 10, I plus plus. We don't have that in a Python. It looks different. I'm going to show you how it looks in a second. But yeah, it looks totally different. But the concept is the same. Yeah? But it looks different. All right, so before anything, I'd have made this page available to you, the Notion page as well as this page. This link is there. We're going to be using this page as kind of like a guide for us to keep track of where we are and to focus on the different parts of the IoT stack that we're going to be looking at. All right. I know that a lot of people doing final year projects that involve an IoT component, right? The reason this course exists is because from before I started doing engineering, there have been projects that were very heavily web-based. Okay, 1 second. 1 second. Let me pause this. Liberty looks like. So she let me know. Right, so yeah, we can talk about that part after. But yeah, so from before I started engineering, there were projects that were heavily web-based, right? But the information that was needed to get it done, as far as I know, was not made available in the program, the engineering program, whether it be electronics or electrical power never existed before me. Biomed never existed before me. I did computer engineering, and that don't exist now. So there was electronics, computer engineering, civil. I think that was it, right? If you wanted to get any kind of web-related knowledge, you'd have to go into ComSci. Fortunately for me, there was a web development course in my program, but it was just front-end development. There was no back-end development that I had access to, right? So I mentioned a while ago front-end and back-end. That's something that we're going to be focusing very heavily on, mostly the back-end. I have taught front-end development in this course before, the first time I taught this course, but it made the course very long, and I'm being told now that even though I took it out, I may have to put it back because the students need it for their work. The reason I took it out and I felt comfortable leaving it out is because, like me, if you need to learn something for your project, you will learn it. You don't need to be in a class to get it done. You will learn it. But if it's a case where I can fit it in and I can at least give you some introductory knowledge on it, then I can provide that. But I don't want to focus too much on the front-end related stuff. I want to say front-end, that's basically website development, web page development. So I mentioned that it is a Python course. It is also very largely a web development course. And when I say web development, you're basically going to be building apps but not necessarily phone apps. Them can work on your phone, but only if you have a browser on your phone. So it's not going to be a native Android or iOS app. Yeah? It's going to be a web app. So just like this here, this is technically an app. It's a web application. Right? This is the front end. What we're looking at now is the front end of an application. It is the part that you as the user will interact with. You want to go on a particular page, you click on a button or you click on a link, and a request is made to some server, and the server interprets that request as information and then give you a response. And the response is the new page that you want to view. Yeah? Not every application that you use has a front end and a back end. Some of them are only front end, some of them are only back end, some of them are both. This particular application is only front end, meaning when you click on something, it does not necessarily go off to some server that has to do any kind of processing to give you back any information. This is a case where you're familiar with HTML? Yeah? Yeah, so HTML, yeah. HTML is a language that we will maybe be looking at that can teach you how to build websites simply. Yeah? If you have a collection of web pages that don't need to do any kind of processing or any kind of data handling, then your application will be largely front-end only, right? You click on a link, it just takes you to another page. It don't need to take any input from the user, like you don't need to calculate anything, you don't need to do any kind of processing, right? That's what this page is. This page is just a bunch of text written out, and style it, make it look pretty, and then it's just in a folder. Whichever one you click, it takes you to that page, right? So it's just front-end only. A type of application that would require a back-end would be something that allows you to, or allows the application to take input from the user and give you an output depending on what that input is. Simple example, Instagram. Instagram is an example because when you go on Instagram, you don't just go on there and look at things. You can interact with it. You can see a post and you can like it. You can leave a comment and you can upload your own content, right? The fact that you're able to interact with a particular post or even create your own post means that more than likely it would require some kind of service running in the background that you don't have access to, direct access to, that handles all of these requests or all these tasks that need to be done, right? So for example, you have a post that you want to upload, you want to share a picture or a video, right? That video may originally be on your phone because you recorded it with your phone and you want to upload it to Instagram now. When you upload it, it needs to go somewhere. It doesn't stay on your phone because if it stayed on your phone, other people wouldn't be able to see it. So that video or that picture, along with whatever caption you have, is uploaded onto Instagram servers and it is served by their server so that anybody that wants to see it is able to access it as long as they have the permission or the accessibility to access it, right? So in a case where some kind of processing needs to be done, or if it's a case where everybody needs to be able to communicate or interact with a particular resource, more than likely, some kind of back end needs to be involved. In the context of IoT now, a large reason why we have backends is because, one, we need somewhere to store the data that we are recording or measuring with our embedded systems. If we're not recording, maybe we need to do some kind of processing. Like, for example, one of the projects I saw yesterday where a student is monitoring power consumption from a building, right? You have a sensor on a microcontroller, and you are measuring the voltage and the current from the grid or from the breaker. After you measure that, you want to take that information and you want to send it off somewhere to be stored. Yes, you could store it locally on an SD card on the microcontroller, but if you have it stored on the microcontroller and the SD card, nobody else has access to that. You want to be able to share that data so that people on a website can look at it and see a table or a graph or something pretty, right? So you take that information that is being measured by the microcontroller and you send it off to some server on the internet. When the server on the internet gets it, it look at it and it's a voltage, yes, this is voltage. It's a current, yes, this is current. And it's when it verifies that those two things are what you say they are, it stores them in a location. And it stores them. You guys would have done any kind of database related stuff before in Dr. Raki's class, I think? SQL, okay, right. So you're familiar with like SQL tables, right? Tables, you have your columns, you have your rows and all that, right? So if you have a table labeled power, it will have 2 columns, 3 columns maybe, voltage, current, and a timestamp. Yeah? Because you need to know when that data came in. Right? Hold on. Right. So you need to know when that data came in. So you may have 3 columns. You want to be able to store that information so that it can be referenced later. Yeah? So your backend would be in charge of accepting that information, verifying that it is valid, and then storing it somewhere. And in addition to storing it, if it's a case where somebody needs to get it back later, meaning you need to be able to populate some web page, you have a web page that also makes a request to the same server asking back for that information. So we have 2 paths in this case. We have an electronic device that is sending information to the server, and we have a web page that is requesting information from the server. So the way how it's going to be working, let me see if I don't know if I have a picture. Yeah, this is not going to load up. I'm going to find it in a second. But yeah, the way it's going to work largely is that you will have some central location where all the processing and all the data is stored. And then if you want to add to that information, or if you want to modify it in some way, you make a request to add some information, to modify the information, to delete the information. And then if you want to be able to see that data or the information, you make a request to get that information. Right? So that would happen on a different place from the website. Questions so far?
Okay.
Make sense? Okay. Come again? If it can go one way, what do you mean?
Like, you can have say for example, you have like a window and you're only receiving information from the server and you're not sending back anything.
Okay, in that case, yes, it can go one way, but question for you. You said a weather app?
Yeah.
How would that information have gotten there on the website in the first place?
The app will receive it from a server.
Right, okay, so it would have received it. Wait, come again? The app would have received it from the server. What I want to know is, how would it have gotten on the server in the first place? That's what I'm asking.
I'm not sure, would request it from the server?
Okay, let me see if I can answer the question. So you asked if it could be one way. If it is a case where you have a weather app and you just want to check the weather in a particular location, yes, it would be one way in that you as the user would be viewing the information on the server. But what I'm asking you is, how would the information have gotten on the server in the first place? Let's say, for instance, you guys familiar with weather stations? Yeah? So you have a device that's deployed out somewhere where it is exposed directly to the conditions of the environment. It will tell you if rain falling, it will tell you how much rain falling, it will tell you what direction the breeze blowing. That setup might have a microcontroller on it that is connected to the internet, either by Wi-Fi or maybe by cellular, right? It is going to be collecting information and it is going to be relaying it to that server. So that's how the information would have gotten on the server in the first place, in that particular situation. So the data that you're looking at, the temperature data for Kingston, something needs to measure that. And when it measures it, it needs to send it to the server so that it can be read by the users who need to know that information. You get me? So in a case like that, it is entirely possible for it to be one way, but if it is a case where you're consuming data, that information needs to get there on the server somehow. Yeah? Yeah. I'm looking to see if I can find my diagram. Yeah. One sec. Pause. All right, I had a diagram that I wanted to show. I'd have shown it during one of the capstone sessions that we were in some time ago, but I can't find it now. I'll see if I can find it later. But yeah, if we can see this. This is essentially how the data communicates from the client to the server. So I'm going to be talking a lot about clients and servers in this course, right? A client is going to be whatever information is consuming the data that is on the server. And when I say consume the data on the server, I don't necessarily only mean when I say consume, I don't only mean getting information back. Consume could also mean sending information. Yeah? Yeah. So there are a particular set of instructions or services that are made available by the server. The services that we're going to be looking at in this class, there are 4 major services: sending information, getting information, altering information, and deleting information. Okay? The server will make those services available to any client that need it. And in the client, it can be your laptop, your phone, your computer, or even your embedded device. Your embedded device is one of those because the embedded device, depending on the situation, would either need to send information, like it measure and then send information, or it needs to get back information from the server because maybe it needs to know what it's supposed to do to the environment it's placed in. So like, for example, if it is a farm, a water irrigation system, a user may want to make it so that they can remotely turn on the water hose so that they can water the farm without them having to go outside and do it. So they have their hose that is already on, the tap is already on, and then they have a flow valve that is closed, normally closed. And they have that connected to a microcontroller. That microcontroller has a solenoid valve connected to it that actuates the valve, right? So with the water already being on all the time, all they have to do is make sure that the microcontroller can turn the valve. The microcontroller in that case is not going to be sending information because it doesn't need to tell the server anything. It needs to ask the server if the user from their phone wanted the valve on, right? So the person on their phone is going to send some instruction to say they want the valve on now, right? And press a button on the app and say they want the valve on. So then now the microcontroller is going to be making a request to the server to ask, they want the valve on now? If it's a no, it just wait and ask again later. It want the valve on now? It will poll, yeah. Right. So you're just going to keep asking, do you want the valve on now? No. You want the valve on now? No. You want the valve on now? No. Yes. Fine. Oh, yes. Then we turn it on now. Then no, you're going to keep asking again. After it says yes, you're going to keep asking again. As long as the answer to that question is yes, it will keep it on. And then eventually when it's no, it will turn it off. Yeah? Okay. Any questions? That makes sense?
And you said that it's called polling.
That's polling, yeah. So polling is something that I would have imagined that you'd be familiar with from embedded systems maybe. So you have polling versus interrupts, right? Yeah. It's not to say that we don't have access to interrupts in our web development. We definitely do. But because of the nature of what we're going to be doing in this course, using interrupts or the equivalent of interrupts in web would be a step beyond what we're going to be doing. So it's not just that it's terribly complex or difficult. It's just I don't want to fry on the brain with a bag of things all at once. We start off with polling, and then if we have time, we can go into interrupts or the equivalent. Okay. So let me see. Okay. What we're going to be looking at is how to build what is known as an API. API, hello. An API is an application programmable interface. Is programmable or program? Let me look it up real quick. API. Whoops. API. Application programming interface. And going back to this diagram, what it means is that, as I told you, the different services that we have made available by our server, that is going to be exposed on the network or maybe the internet using an API. So you as the client, whether it's your phone, your laptop, your computer, or your embedded device, needs to be able to access that API. You make a request to the API, and then the API delegates that request off to whichever service needs to get it. So the API stands up in front of the server or stands up inside the server, looks at the request, and determines where this request needs to go. If it is a request to add some information, the API can look at it and say, oh, this is an adding request, send this to the adding section. Look at it again, if it's a get request. Yeah, basically, yeah. Okay. So a lot of the time you may hear me alternate between API or server. They're not the same because the API stands up in front of the server. The server is technically the computer, or it is the API is the interface. It's the interface that the clients use to access the services that the server makes available. Yeah. So we, as the programmers, are going to be writing functions that handle these incoming requests, and we're going to put an API in front of those functions. The API will get the requests and direct those requests to whichever function it needs to go to perform the action that we want it to do.
So, question, you made reference to testing for the power and asking to recognize the voltage in the current. This is a case where the API is used to verify the information before it's into the server.
Okay.
Or it just takes it and sends it.
The API just looks at the request and sends it where it needs to go. So the API don't do the verification. Your function that you write in the code is what does the verification. Yeah. I was going to make a comment a while ago. Usually I like to tell students that when we're doing our programming, nothing is automatic, but that's not necessarily true. A lot of it will be automatic. What I mean by that is we don't have to write or configure the API very much. The API that sits in front of our code, for the most part, it's supposed to know by itself if we get a request to add some information, that this function must get it. We don't really have to do very much coding in that regard. But we will see how the program will come into being when we get there. Okay. So yeah, where am I? The 4 different types of services that we're going to be using. Oh wait, no, actually I think I need to talk about this first. Right, so the protocol that we're going to be using, before we get to the services that we're going to be creating, the types of requests, the standard that they follow, the protocol they use is called HTTP. Hypertext Transfer Protocol, right, yeah, I can never remember. Yeah. We don't really need to know what HTTP is, but we need to know what it looks like. We need to know how to use it so that we can create a request and handle the requests when they come in on the server. But before that, we need to look at the different kinds of services that we have access to when we're making HTTP requests. So I said that there are 4 of them that we're going to be looking at. It's not 4 though, it's significantly more than 4. But we only need to know about 4 of them, for the most part, maybe 5. And I'll tell you why maybe 5 in a second. But first, let's take a look at this. So I told you that it is entirely possible for us to make a request to a server to add some new information. Anytime you want to add some new information, typically, tradition says we use a post request. So that's like when you want to make a post to Instagram, we make a post request. Yeah? It is not always to add information, but anytime you want to send something to the server, and the server is supposed to take that information and do something with it, anything at all, we typically use a post request. The reason why I say it's not always to upload some information is because suppose you have an application where you need to be able to have users log in before they can use the service. If you need to authenticate a user, you typically ask for what information? When somebody logging into our website, what do you ask for? Or the website asks for? Username and password, right? All right. When the website asks for the username and password and you click submit or login, the website will take that 2 pieces of information, username and password, and it will make a post request to the server because you're providing information to the server and it needs to do something with that server. Because you're sending information to it, it should be a post request. Traditionally, typically, it's a post request. You're not uploading anything, but you're sending information for some kind of processing. We typically use a post request. Yeah. All right. So some examples that it gives. Let me see. Key properties. Right. Down here. So creating a new user account, that would be like if you're going to register for our site. That one is more like uploading because you're giving the website some information that it now needs to store and remember for later purposes. That's more like uploading, yeah? Even though it's not a picture, it's just text. But that would be more akin to uploading. So we use a post request when you want to create a new user account. If you want to submit a form, that's also like submitting. So you have your Google Forms that you fill out that it needs to be stored in some database for later use. We use a post request for that. Uploading a file, that one's straightforward because that's uploading. Adding new information or new blog posts, posting sensor data from an IoT device. We use post requests for that, yeah? Questions? All right. This one now should be also self-explanatory. A GET request. It is a type of request that we use in our HTTP setup where we are requesting for some information on the server. Yeah? You have some information on the server. You have sensor data that you've been sending from your microcontroller for days and weeks and months. And now you want to visualize that data on your website. Your website needs to be coded in a way where when you open it, it automatically makes a GET request to the server asking for the information to be displayed on the page. It uses a GET request to retrieve that information from the server. You have a embedded system, a circuit that is sending information to the server. It's collecting its sensor data and making post requests to the server. The website now needs to make a GET request to the server to ask for that data so that it can put it on the web page. Yeah? So the website, yeah? Yes. Yes. The website needs to make the GET request to the server.
It's different from the web page.
No website, web page, same thing.
It says like once you post that the GET set up already, to just constantly be checking.
On the web page, yes.
Like,
The web page should be built in a way where either it is a constant thing where it's keep on getting, or it's just at the beginning of the web page when you open the web page for the first time.
so in that case, you have to reload.
Yeah, right. If it is a case where you have some new data that needs to be displayed on the page, then you'd have to reload it. Or you write your code in a way where it reloads itself automatically.
Probably some SSM, so automatically reload.
SSM? I'm not familiar with that. Okay. The reload automatically is something that we can look into later. But yes. So we use a GET request when we want to retrieve existing, oh, you know what too? Something that I didn't mention with post requests. Well, all right, no. I can show you what a post request looks like after. It will make more sense. I have to explain it after. So yeah, we use it to load a web page. When I say use it to load a web page, what I mean is the web page that we create is going to be stored on some server. So when you type in a URL into the bar at the top, that is you making a GET request to this server for this page or for this resource. Yeah? So the server in my case is IoT devguide.netlify.app, that's a server, and I'm making a GET request. I'm requesting page request 1. Yeah? And then the server responds by giving me the page. So the browser knows that when it gets back a page in a particular format, it's supposed to render it in this form. It's supposed to render it in the way that it was designed. So the browser knows that it's supposed to take the information, even though it's just text it getting back, it's supposed to make it look like this. So this is a GET request, or this is the result of a GET request.
How the browser know to lay it out like this? Are you designing it?
Yes. So there are different pieces of information that come back in the response from the server. One of those pieces of information is how the page must look. So when the browser gets back that instruction or that information on how the page, it gets back 3 things, typically. It gets the content of the page, how the page must look, and what the page must do.
So you basically send the instructions.
I just send the instructions, and then the browser just bill it. Yeah, that's essentially what's happening. Yeah, right. Because yes, largely this page is text-based, but we have our colors, we have our emoji, we have this on the left and this on the right. The browser needs to know how to construct that information, right? The response from the server is just text, is straight text. When it uses that text, it reads it like a recipe. It's supposed to put the word definition at the top, and then after you write the word definition, it's supposed to put a paragraph that says the post-it method, it submits whatever, blah, blah, blah. And then after that, it's supposed to put an emoji here, then put the word key properties and so on. And it just read that information and just put it on the screen in that way.
And all of them are like based on positions.
Right. All that information, position, color, size, all that stuff is sent from the server. Yeah? Right. So I said loading web pages, fetching profile data, retrieving search results, getting lists of products, and reading sensor data history. So we'd use GET requests for that. The last 2, I imagine it's self-explanatory in a way where I don't really have to go through it too much, but also go through it. A put request. We use a put request when you want to be able to alter some existing data. I told you that we're going to be looking at 4 services or 4 types of requests, maybe 5. The reason I say maybe 5 is because there are 2 ways that you can typically alter existing data. You can use a put request or you could use a patch request. The difference between them, typically a put request based on the instructions and the traditional documentation given to us by the people that invented HTTP. We use a put request when you want to alter an existing entity completely. So you want to alter everything about it. You have some properties of your data. For example, if it is a weather station, no, you wouldn't alter weather station data. Let's look at profile data, user profile data. You have first name, last name, age, first name, last name, date of birth, favorite color. If you want to be able to change everything about that user profile, we use a put request. But if you wanted to make a small change, a fractional change, we use a patch request. So typically, based on the documentation we get from the HTTP people them, we use a patch request when you want to make a partial update and a put request when you want to make a full update. The thing is, even though the documentation says we use a put request to do an entire update and a patch request for a partial update, you can use the two of them to do either one. It is entirely dependent on how you write your code. Yeah? But the thing is, the documentation that's provided to us states that if an API is written and it exposes a put request, it should perform an entire update. Should.
That means first preference.
Yeah,
unless stated otherwise.
Yeah, right, exactly. That's correct. Yeah. So that's first preference unless stated otherwise, typically. So if it's a case where you, as a developer, are given a fully built API already, and your job is to interact with the API or write some code that consumes the data on the service, if you see that it's a put request, you can assume, unless otherwise stated, that the put request is expected to take an entire change to an existing entity, and everything that you have specified in your change will be used to replace the version of the entity that exists on the server. But if it's a patch request, you're only expected to provide a partial update, unless they specify otherwise.
I understand. So even if that case where, so for example, you have the username and the password, but we're going to put in a put request, even though you don't change the username or change the password, it updates it either way because it thinks that.
Right, that is correct.
That's
Yeah.
why you can use it as patch or just.
Right, that's correct. Yeah.
You can use put on control circumstances.
What do you mean?
Instead-
Oh, like settings?
Yes, instead of it have to change everything in a certain parameter. Yeah, with constraints, so it only changes.
So it very much depends on how you write your code to handle it. Yes, it can be done that way. I'm just saying, I'm teaching it in a way where that it lines up with the official documentation. Yeah? And I can give you access to the documentation. It's, let me see, RFC, is it RFC docs? Where would I go? Let me see, put. RFC put request. Where are the RFC docs? Patch method. Where do I have it? All right, maybe this is not the version that I'm remembering. I think the version I remember is like 9,000 something. But yeah, if you ever want to know how a particular request is supposed to behave, you can look up the RFC documentation. So this is RFC documentation for a patch method. It basically tells you how you should write your function that handles a patch request and what it's supposed to do in the event that it is a successful request, what if it's an unsuccessful request, and all different kind of things that you need to do. Right, so we can take a look at that later. Let me see, where am I? So yeah, we use a put request when we want to alter existing information. Updating user profile information, modifying product details, and all the rest, yeah? And then last one, the delete request. That one, we use it to delete existing information, right? So you have something on the server that you don't need anymore, you delete it. Supposed to delete it, correct, yes, supposed to. The reason why your colleague says supposed to delete it is because in the industry, we have a logical delete different from delete. So delete by itself is supposed to mean you have some information on the server, it is supposed to be removed and inaccessible or removed. A logical delete just means don't remove the information, just make it inaccessible. Yeah. So yeah, I don't know if I'm allowed to tell you, but I'm sure you guys won't tell on me. When I worked at NCB, if at any point you make a request to delete some information, it still stays on their server. Them just make it so you can't see it anymore. Yeah? So it's still there. Yeah? Yeah. Come again? You mean after it's deleted?
Yeah, in case it deleted for some unscrupulous reason, they can trace it back.
They can trace it back or for auditing purposes. If it's a case where they want to know what the state of this person's account was in the past, after it's deleted, at least they can still do it because the data is still there.
So that's what they can use that program, they go back. Program where they can go back and see state of a website.
Why is that? That happens because they said that the internet is permanent. It's the information is still stored somewhere. You get me? I'm not sure if it's exactly related to what I just said a while ago, but in a sense, yes. So it is not a case where somebody may have intentionally decided to fully remove it, but even though it was removed by this person from this place, somebody else might have still stored a version of it somewhere else. You get me? So yes, it was intended to be removed, but somebody else has a copy of it stored somewhere. So it's kind of similar, not exactly, but yeah, similar.
So just to go back, you have logic delete and what else?
Logical delete and, I don't know, I guess just call it delete. Delete and logical, yeah. Yeah. Yeah.
But the thing about it now, sir, right?
Mm-hmm.
And the put and patch request for an update, right? So for example, you have first name, middle name, last name, password. And I want to update to just ask for the first name and password. When I update that, the middle name and last name, delete.
Okay, that's a good question. So remember earlier when I said nothing is automatic? The answer to your question is it is entirely dependent on how you write the code.
So my next question is that can I use the put and patch to delete as well?
Okay, I hate that you asked me that question, but it's a very good question. It's a very good question. So, the reason I don't like that you asked is because I feel like my answer will typically fry people's brain. I really don't want to confuse you, but stay with me on this. All along, I've been telling you what the default behavior of these services are, these requests are. And I say traditionally, and I say according to the documentation, and all that nice stuff. Nothing is automatic. So just because you are writing or making a post request, don't mean it has to act like a post request. You can 100% use a post request to delete something. You can use a patch request to get something back. You can use a get request to delete something. You shouldn't, because that's going to go against the documentation. And if you're going to be writing your API that's supposed to be consumed by other people that are writing application, they are going to get confused. And you need to meet the standard. You get me? Yeah. So you can do it because you're the one writing the code. You get to determine the behavior of how the code works or how the service works. So you can do foolishness. You can make it very confusing, but please don't. If you want to know something works, use the RFC documentation or use the information I provide to you in the course. Yeah? So you definitely could, but don't. It's a very good question though. RFC, yeah. I'm going to see if I can find proper links and share them later. Because the thing is, the RFC documentation update all the time. So it might be a case where, it might have been a case where one time somebody would have said, for a put request, put requests are typically used for updating existing information. But I've seen in documentation before that says, if you're trying to update a resource and it don't exist, create it. Yeah. I don't personally like it. It can work based on the use case. But it is in the documentation to say, if you're trying to update something that don't exist, create it and then change it. You get me? So it would be like a put request could be considered similar to a post request. Because a post request is supposed to take some information and create a new entity and store it. But if something, you think it exists and you try to change it and it don't exist, change it, create it and then change it. You get me? Yeah. There are other cases where, if it's a case where you're trying to make a put request and the thing that you're trying to change don't exist, the server is supposed to respond and say, this thing don't exist. This thing that you're trying to change don't exist. Right? So it depends. The documentation changes all the time. Yeah. So yeah. Yeah.
When you say API, is the API the server?
Okay, good question. You came a little late. So typically I will alternate between API and server. They are not the same, but they live in the same place. The server is going to be the behavior of your web application, right? So whatever it is your server or whatever it is your application is supposed to do, the functionality of it is dependent on your server software. The API sits in front of the server software. The API is what takes the request and delegates where each request is supposed to go. So the API takes the request, and if it's a post request, it gives it to the post request function on the server. If it's a get request, the API will take the get request and give it to the get request function on the server. Yeah? So they're not the same.
So it's like the server database?
It's not the database. The database is where information is stored. Come again? It's a middleman. Yeah.
So it's like,
It's when you go into the bank, as soon as you walk into the bank, security asks you what you're here to do today. I want to do a car loan. All right, go to that teller over there, so. Or I want to do a deed. Go to that teller over there, so. I want to deposit something. Go to that teller over there, so. So the API is the security guard that's set up in the bank that tell you where you must go. Yeah. Make sense? And I was saying that we don't really do a whole lot of interaction with the API. The API kind of just is something that we download and install, and we tell it to run. And based on how we write our code, the API will know and understand where to send the request to. No, we don't really program it. No, we don't. No, it's not. We use VS Code just to write the code. VS Code now nothing to do with our server.
we build a server in VS Code. So what is the API?
I'll get to that in a second. I cannot have an answer for that, but I'm going to get to that a little bit later. I don't want to fry your brain just yet. Come again? You can modify different properties of it, yes. Not very many, because we typically don't really need to. I'll get to that in a second. Remember your question. Okay. All right, let's take a look at what a request looks like. So let me see. HTTP post request. Okay, I don't love this one, but it's okay. Okay, so an HTTP post request. The post request itself has different components to it, yeah? First thing, this is the entire body of the this is not the body. I don't like to use that word because this is the body, but I'll explain that in a second. This is what a post request look like. We know that it's a post request firstly because the first word in the information is post, right? So we say post, and then we need to tell the request, or the request needs to know which function is supposed to be handling this request. Okay. The function that's going to be handling this request is called test. Yeah. So it's a post request that is going to the test function. This is either going to be, in your case, post, get, put, patch, or delete. This test, however, can be whatever you write your code to be. Yeah? So if it's a case where you're writing a post request that's supposed to handle user login, you can call it login. You can call it register. You can call it sensor. You can call it data. So,
That function is a multi-server.
right. So this is the name of the function that lives on the server. Right. This part we don't really need to know, but it's part of the standard for the application to be considered valid as an HTTP request. So we're telling it what version of HTTP we're using. I think at the moment there's version 1, there's version 1.1, there's version 2, and I think there's version 3, but I'm not sure. I think it's stopped at version 2 though, but we'll be using version 1.1 for no particular reason. The reason is because I don't know how to use version 2. Oh yeah. All right, so that's the first line. The next line, the host is where the server lives. This server lives at example.com. Now let me explain what I mean by example.com. All right. If I were to say that I'm going to go, after class, I'm going to go Sovereign. You guys know where Sovereign is, right? I didn't have to tell you that I'm going to go to 106 Old Hope Road, Kingston 6, right? Because you know that when I say Sovereign, I mean the building located at one or so blah, 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 right? Sovereign is the alias for that address. So the address is the physical location, and then I use a nickname or an alias to refer to that location in space. Example.com is an alias. So I say example.com, and even though I'm not telling you exactly where that is, you know where it is. Well, you don't need to know where it is, because all you need to know is that I'm going to this place called example.com. I'm going to go to Sovereign. I don't need to tell you where Sovereign is. Come again?
The address would have been the IP.
The address, the physical address that this is referring to is the IP address. Yeah? So the IP address now is the physical location, yeah, kind of the equivalent of the physical location of that server. So IP address. So IP address typically looks like this, yeah? 17.172.224.47. This information you'd be able to know, you'd be able to use to find out exactly where on the internet this service lives or the server lives. Typically, IP addresses are associated with a physical location. So you might be able to look at it and say, if it starts with 17.172, maybe that's South Africa, or maybe that's Mongolia, or maybe it's Serbia, or maybe it's Jamaica, or maybe it's Canada, right?
Okay.
Yeah? So you'd be able to look at a particular part of it and you'd know which physical location it is associated with. And I'm not sure if you can get more granular than that. I don't think you'll be able to tell, oh, this one is New Kingston versus this one is Mobe and so on and so forth. I don't think you'll be able to do that. I think for the most part, it should be able to tell you country, maybe.
And then other features like maybe GPS and what they're connected to.
Right, depending on that, you'll be able to get more granularity. Yeah?
Each country have different characteristics.
Yeah, yeah. So yeah, I do believe that is the case. It's not something I've looked too deeply into, but I believe that is the case. So different countries have an allotment of IP addresses that are associated with them. Yeah? I want to feel so, kinda, yeah. Because, all right, as you said that, okay, the websites that we use, we know a bunch of different websites that end in .com, right? But it's not only .com exists. We have .org, we have .co, we have .io, we have .tv, we have .ia, or AI rather, we have a bunch of different blah, 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 blah. .com and .org, I believe those are specific to just the internet. But all the others are related to a country. Every single one of them.
UK and .o.
Yeah, but that's not just that. Because look at this, let me show you. Top level domain. List. Let's see. Oh, .NET is also one that's internet related. Let me see if I can say actual proper list though. By country. I want that easier to use list. Alright, this is fine. Alright, let me look for .io. Anybody know any sites that are .io?
IO.
Yeah. Draw.io. So IO, when you say draw.io, you might think IO mean input output. But no. .io mean
Internet computer,
All right, me never know that. I thought it was Indian Ocean. Hold on. Hold on. Let me see. Indian Ocean domain. Yeah, it's IO. IO is it's the domain that is associated with countries of the Indian Ocean.
It's delegated by.
Come again?
So that's who created it.
Oh. Is it in the Indian Ocean? Okay. I don't know. That's interesting. But yeah, before that it says normally assigned to British Indian Ocean territory. But I guess it's managed by these people.
Yeah.
I don't know what that means. So yeah, anytime you say any kind of, well, okay, actually in modern times it's kind of different because you have like that party and you have that restaurant and all them something there. Those aren't associated with any country, obviously. But like, if you see .io is because originally it was dedicated to websites that are created in the British Indian Ocean. Oh, this. 1 second. Sorry about that. Right, so yes. IO is for Indian Ocean. Let's see, there's another bunch of other ones. What's AI? .ai is Anguilla. Yeah. So anytime you send a website that have anything to do with AI, they're not stealing, but they're using the domain that is allotted to Anguilla or Anguilla, whatever you pronounce it. Yeah.
So what I want to know is that question is with paying for it. Do the government of Anguilla pays for AI domain? Because I know like they have businesses where we pay for a domain.
Right.
Within
So here what? I believe it is actually a case where they're getting the money for it.
The company?
The country, I think so. I need to check that, but I believe so. I think so. Because you know that we have .jm. You know who manages .jm for the whole of Jamaica? MITS. MITS. I don't know if it's still the case now, but many years ago when I was in my undergrad, one of my brethren bought a .jm domain, and it's MITS him have to go for buy it. So MITS manage it. And if MITS burn down, all the .jm them gone. Well, not necessarily, but yeah.
So they must serve.
Yeah, that hosts it, yeah. So every time you go to a .jm website, the request go to MITS first. And then MITS tell you where the website exists or whatever, yeah?
So, alright, I'm going to ask you, like, what's MIT's role in this case, like an API?
MITS's role is a name server. Let me explain what that means. Name server. So, let's see, which one's good? All right. Let's say, for instance, you did not know where Sovereign was. I tell you, somebody asks me, all right, somebody come to me and say that they want to go to Tutti Frutti, because Tutti Frutti is in Sovereign, right? I tell them they need to go to Sovereign. They don't know where Sovereign is. So what they're going to do now is they're going to, which one is it? So this is the person asking me where Tutti Frutti is. I tell them it's at Sovereign. They need to now go over here and ask this one, where is Sovereign? When they find out that Sovereign is 106 Old Hope Road, then they get redirected to 106 Old Hope Road. Because this is where Sovereign is. But this don't know that. This just know that Sovereign, no, this knows that you need to go here to find out where Sovereign is. This knows where Sovereign is, and this is where Sovereign is.
Alright.
So this
one is MITS?
This one is, wait. This one is me. Wait, I don't know. I'm not sure. I'm not sure. Which one is me?
So ideally, I think maybe MITS would be the one who knows where Sovereign is. I know said Tutti Frutti is in Sovereign. But you have to make the request.
Would that be the whole internet?
Let me tell you. I think the part that Sovereign just know about the .jm part. So Sovereign will tell you that if your website ends in .jm, go to this place, because this know where all the .jms are. So I think this is MITS.
That's MITS.
I think so. I think so. Because it's top level domain. If you get a request for anything .jm, it goes to this server. This server says, yeah man, if you want a .jm, ask this brother. He will tell you which this website is.
Okay, so, alright, until if like if the name is available or whatever you use.
Well, not if it's available, because remember, we're assuming that this thing already exists.
Okay.
So for example, sovereign.jm. You ask this server, you ask me, where is sovereign.jm? Since he says .jm, ask this guy. This guy know where all the JMs are. And then this guy going to say, yeah man, sovereign.jm is 192.168, blah, 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 blah. And it's up here, so.
So question,
Yeah.
in this scenario, can one entity be both?
I mean, I guess, yeah.
Yeah.
Because all these services run on computers. But they dedicate different servers for different roles. So yes, it physically could be, but I don't think that's how they do it.
Oh.
Yeah. It's a fair question though. Any questions on this? Yeah? Good?
So if it's a middle one, that it makes much more weird the specific addresses, then what would the private DNS part of this?
You see, because this is not really IoT. We don't really fully know the details of it. I just know the high level stuff. But my understanding is this knows where all the .jms are. Or no, sorry. This know that if you want to know where a .jm site is, ask this server. Because this server is controlling all of the .jms. And then this will know, when you say sovereign.jm, it actually means 192.1 blah, 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 blah. And then that's where that is. So this is telling you to ask this guy. And this guy is telling you, oh man, see it here? Yeah. Yeah. Well, this know .jms only. This know that this know .jms. And this know where this is. Yeah, it's a bag of rerouting. Yeah. And a lot of the time it's going to be a whole lot more than just 2 or 3 steps. It might be 50 steps before you can actually get where you want to go. Okay. Right. It might take a whole lot more steps, yeah. Yeah. So if you're in New Zealand and you want to get a .jm server, this person will have to ask this person, and this person will have to tell you to ask this person, and then so on and so forth until you get back to MITS.
So like that jump.
Yeah. Yep. That's correct. That is correct. All right, so back to this. So example.com is an alias for an IP address. I specify that as important because when we're writing our code, a lot of the time we're going to be using IP addresses. Because typically, you have to pay for domains. You don't always have to pay for them, you have free services, but we're not really going to get into using the domains for our services. We're just going to use the IP address. So in a case like this, we just replace this with 192.168 or something. Yeah? Okay, so that's where the server lives. Content type. Content type is important because the request needs to know the information that you're sending in the request. It needs to tell the server how the information is formatted. This is the formatting of the information. This is the information. So right now, this looks like a bag of gibberish. But because I know what it's supposed to be saying, I know that it's saying field 1 is a variable, and the value inside that variable is value 1. So it's field 1 equal value 1. So this could be like num equal 40, right? And then there's more. The more is in addition to field 1 equal value 1, there's a next variable called field 2, and that variable is equal to value 2. So we have field 1 equal value, and just means in addition to this, there's more. So it's this. Normally when you're writing your code, you probably put in a next line, or you end the semicolon. This ampersand is telling it that this is one piece of data, this is the next piece of data. So you have field 1 equal value 1, and field 2, you can add a next one, put an and right here, and say field 3 equal value 3, and field 4 equal value 4, and so on and so forth. This format of representing data is referred to as URL encoded data. The URL encoded is just the easy name, but this is the whole name. Application / all that.
This data will be sent to the website.
Right. To the server. To the server. And it's sent in this format, the URL encoded format. We are not going to be using the URL encoded format.
Okay.
We're going to be using a format known as JSON. 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 JSON or JSON. Yeah? Right? JSON. That stands for JavaScript Object Notation. It don't mean that you need to know JavaScript, but it is a format that is created for the use of JavaScript, but it can be used outside of JavaScript. Yeah? Content length is how many characters that make up the body. All right, I didn't specify. This is the body of the request. Yeah? So this is the whole request. This is the body of the request. So post requests typically have a body because the information that you're sending needs to be it needs to be stored somewhere in the request. It is stored in the body. And we know that is the body because, well, if I use my own undergrad knowledge, the body is typically 2 lines below everything else. That's how I remember learning it. It's the body because it's 2 empty lines below. Yeah? And when I say the content length is the number of characters, I literally mean the F, the I, the E, the L, the D, the 1, the equal sign as well, the V, every single character. As long as you can see, even if you can't see it. If there was a space, if there was an enter, you count the enter. As a matter of fact, if there was an enter that go into the new line, that counts as 2. Because enter is, okay, you know that already. So yeah, enter is 2 characters. Because enter means you have to bring the cursor down here, so, and then bring it back. So that's 2 steps. You bring it down, then you bring it back. Yeah? So that's 2 characters. Yeah, this is URL encoded. What we're going to be using is JSON. I'll show you what JSON looks like. Yes.
Content type. What are the name for that specific part?
For which one?
You have to put the content type when you create the whole thing in the base code. You put the content type and the application. So we call it 2 different things.
This is the league, like the government name. So you have to put the application part there first. So this is not the content type, but you have to tell, well, the full name for it is application/x www format blah 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 blah. Yeah? So this is just the name. It's not that you're specifying 2 names. This is the whole name. If you wanted to specify JSON data, let me see. Let me copy this. Open Sublime. It would look more like, oops, this. So I start off with a curly bracket right here, so and go so. That, and put a comma here, so. That, and that, oops. So this is what a JSON would look like, a JSON body would look like. Instead of having field 1 equal value 1, you'd have your open curly brace, then you'd have in double quotes, the name of the field, colon, and then the actual value, then a comma, the name of the field, in double quotes, colon, the value itself. And then you close your curly braces. If you had more, you put another comma here, so and you keep going. Yeah?
So you have to count the brackets.
You have to count everything. You have to count the brackets, you have to count the enter, you have to count the tab. So this empty space right here says is a tab, that's 1 character. Or if it's not a tab, it's space, like 4 spaces, you have to count all of them. You have to count the double quotes, this is 1, even though it looks like 2 things. That's 1. You have to count this, you have to count this, count the space right here, so count that, count everything.
Alright, now that leads to a question. What's the difference between the
URL encoded?
URL encoding format and the JSON? And then follow-up question, why use JSON if it take up more space?
That's a fair question. I don't know the answer to your second question, but yeah, it's more readable. JSON is more readable than URL encoded. And it very much depends on the system that's accepting the data. It is not to say that we're never going to use URL encoded. There are cases when we definitely will. It's just that we're not typically going to be using it as the body of our request.
Okay.
We may use it in other places. I'll show you later how we can use it. Yeah? Since we made a change here, we need to make a change here. So we need to change the content type from all of this to JSON, application JSON. And also, we need to change this, the length. I'm just going to use Sublime here to tell me that this says 44 characters. So I'm going to change this to 44. Yeah, and now it's valid. Yeah?
Go do that thing again.
What I do? Oh, I highlighted this and it tells me 44 characters selected. I don't know if it's actually considering the enter and all them something there.
They said it. That's why I asked you to go back. So it said 37, but with the space is 44.
Oh, okay. Yeah. Okay. So yeah, 44 characters. Yeah. And the thing is, if the content length wrong, when the server get the request, it will take this over the actual data. So if it's the body is 44 characters long, it will read from the beginning all the way to the 44th character, and if there's more after, it does not go pre. Yeah? Because you're telling it the data is 44 characters long. So if you're saying it's 44 characters long, I will use the 44 characters. If it's a mistake you make, you never know that. If it says 44, that means it's 44. If you put more than the 44, you ever get an error where like you're trying to read an address that you don't have access to in C? Like you have an array that is 4 characters long and you're trying to read the 5th element. You're reading data from a different, you're going to get, you may either get an error or you'll actually start to read information that you did not intend to send. Yeah. Yeah. Questions on this? Yeah.
Can you do the reverse? Can you have a body and want to know the length?
Yeah? Yeah. Okay, actually, that's a fair question. Again, I say nothing is automatic, but because of the different libraries and the frameworks that we're going to be using to write our code, you typically don't need to manually specify the length. The applications that we're going to be using have features built in where whatever you send, it will just count it for you and it will fill in this blank for you. Yeah? As a matter of fact, we don't actually need to write stuff that look like this. We just call on functions that take the information we supply and it will build this in the background for us. So it will specify that we want to send a JSON that look like this. It will first say, all right, firstly, well, we need to specify that it's a JSON because this, even though it looks like a JSON, it don't have to be a JSON. This could just be plain text, right? And the content type of plain text, I think, is text/text or something like that. I don't remember. So this could be just written as plain text, meaning it could just be expected to be interpreted as a curly bracket and then a double quotes and then some words, right? But if you specify that it's JSON, the server, when it gets it, knows that it's supposed to consider this as information where this is the variable name, this is the value, this is the variable name, this is the value. It starts here and it ends here. Yeah? So we tell it so that it knows how to interpret the information. Right? And then there are things in the background that will count this and then fill in this value for us. So we typically don't need to specify how many characters it is. Yeah? Okay. Let me see. So we covered JSON. What else? This. Methods, status. Okay, yeah, we can look at status codes. Very important for us to look at status codes. All right. So HTTP status codes. When we make a request to a server, we need to give it some information, and depending on whether the request is valid, it is going to respond with some information. We use status codes to understand what the information means. So yes, we can look at the information that is responded to us and just read it and know what it means, but sometimes we don't need to read it. Sometimes we just need to look at the status code and it will tell us what the intent of the response is. What I mean by that is, you make a request to a website and you're trying to get access to a page that don't actually exist. So, for example, if I pull up YouTube/ and I just go so and press enter, this page, actually this doesn't really tell you a whole lot. Hold on, let me look at this here, refresh this. Click on that. I don't know if you can see. Is it? So I made a GET request. Hold on. Can I make this bigger? So I made a GET request to this location. The server is youtube.com, and the page I'm trying to get, or the resource, is all of this foolishness. It told me it's a GET request, and the status code is a 404. 404 means the request I made does not lead to an existing resource. The thing that I'm trying to get don't exist. 404 in this case is the status code. So yes, the response was all of this information, but if I could not read and interpret what all this meaning even though it's telling me that this thing don't exist, I would know by looking at the status code that the request I made is invalid because not invalid. The thing I'm trying to find don't exist. 404 mean the thing that you're trying to get don't exist.
Question.
Yeah.
So in the first one, so all this what we're all about to get into. In the summary say we have some about command status. Regarding to like even the get now them have like 200 okay.
Alright, let's soon get to that. I'll get to that after I answer this question. Yeah.
Back to the whole JM and
The what?
when you look at the YouTube, it says that YouTube JM. So is it that it's using a specific server here to serve?
Okay, good question. YouTube, being a huge company, needs to be able to service the whole world. And it needs to be able to service the whole world without delays. That means YouTube has servers all over the world. If I'm in Jamaica, more than likely, if I'm not using a VPN, the service that is going to handle my request is going to be the one that is associated or assigned to the Jamaica region. It don't mean the server in Jamaica, you know, but it might be somewhere near enough to Jamaica, physically near to Jamaica. It might be in Florida, for example. Yeah. So when you go to YouTube and you say JM at the top, it means that you're going to the server that is supposed to handle the Jamaica traffic. Yeah. You can change it either by going into settings and changing it on YouTube, or you can use a VPN. The VPN will tell whatever server that you're trying to communicate with that you're not actually in Jamaica. You're somewhere else physically in the world. Yeah. So depending where you physically are, the information will come from a different server.
That's why when you like serve from Jamaica, like before you even realize the time was changed.
Change, yeah.
Because you're in a different people.
Yeah, because different networking location, yes. Yeah. Also, that could be physical location because the phones can actually use GPS and tell physically where they are. But yes, that as well. All right. Don't forget your question. So yeah, the example I showed a while ago with YouTube. I tried to make a request to a location that don't exist. The website responded with some information that I can read, but if I don't want to use that, I can use the status code to tell me that this thing don't exist. All right. So going back to, where's my page? Where was I? Wait, was I? No. Status codes. We have different types of status codes. 404 is one of them. We will know what type of code, or rather what a code means or implies, depending on the first number. So I have status codes that start with 1, like 101 or 111 or 110, whatever. We have 200, we have 204, we have 201, a bunch of different 200s. We have 311, 309, 30 this and 30 that. We have 400, 404, 405. We have 500, 511, 512, and a bunch of others. Which one? Oh, 500?
Yes.
Oh, that's not good. I'm going to tell you why. Okay, soon tell you what that means. The 100s, we're not going to use. I have never personally gotten back a status code that starts with a 1. I don't really know what I mean. I could look it up, but they're not really important to me. I am more interested in the 200s, because 200 usually mean good. You're trying to perform an action, you're trying to make a request to a server, you're not going to see it because it is going to be covered up by the information that you want. So I make a request to a server. I am trying to log in. If I'm successfully able to log in, the server, along with the information that was supposed to show you your profile and your account, it would also come back with a 200. So 200, actually hold on, 200 means that the information that you're trying to get back, see it here, and also you're good, you did it properly. You successfully made the request, and here's the information that you want. Yeah? Yeah, so you could make a request to some function to get a user that have an ID of 123, and it gave back the information. Here's the person ID and here's the name, 200, that's good. I mean, you did it correctly, and here's the information. 201 means if you're making a post request and you're trying to create some new information, it means that the request to create the information was successful. It means the thing that you're trying to create was created successfully. 201. So these status codes, they have inherent meaning, right? And again, nothing is automatic except for some things. Even though you are the one that's going to be writing your code and I say 201 means created, it don't mean that in your code you have to return a 201. You can choose to return a 200 or a 204 or a 500 if you want. Don't do that. But if you are creating a new entity or a new object and it's supposed to be stored in your database, documentation says that once it is successfully created, the server should respond with a 201. So 201 means...
Well, I realize that even for the 200, you go for 200, where you produce. So in a case where the response to the 200, we can change the response.
You control what the response is because you're writing the code. So you determine the behavior of the server.
So we can find YouTube and still post up 200.
You can what?
Still searching garbage.
And still return a 200. Yes, you could do that if you wanted to. It would be terribly confusing, but you could do it. You absolutely could, but don't. So here's the reason why I'm saying don't, right? If it is a case where I give you an assignment and I say that you are required to create a function that accepts information from the user to create a new object, your function should respond with the appropriate status code. If I don't tell you, and you successfully return a 400, I'm going to take off marks. You're supposed to know because I'm telling you that when you create a new entity, return a 201. If you're trying to alter an entity and the entity don't exist, if it don't exist, you're either supposed to return a 404 and say the thing don't exist, or depending on what I say you're supposed to do, if it don't exist, create it and then change it. So it depends on very much my instruction to you. Yeah? I need to come up with a standard for what I want you guys to do with put. Because I don't really love the idea of if it don't exist, create it. I prefer if it don't exist, just tell me it don't exist. So maybe I'll give that explicit instruction, and if I don't, you can ask me. So yeah, 201 means create. Wait, did I unpause this? Yes. 201 means created. 204 is a successful status code. Typically means that whatever it is you're trying to do, it do. But there's no more information I need to give you back because you never asked me for nothing. What I mean by that is, suppose you're trying to delete something. If you're trying to delete something, no, hold on. If you're trying to create something, the typical response to that, according to documentation, is show me the thing that I just created. So I'm going to give you the information that I want to create it. Show me that it's created by showing it back to me. So that's the response typically. So if I say create a new object that is a person, them first name is Philip, them last name is Logan, and when you respond, show me it back. So it's like when you're ordering a pizza and you tell them your phone number, you ask them to respond, repeat it back to you. Yeah, to prove that they heard it. So in my case, when I'm trying to make a request that have to create a new person, first name Philip, last name is Logan, I want you to tell me back so that I know that you created it. So once you tell me back, you send back a 201 and you show me that information that I asked you to create. But if you're deleting, so I want to now delete the user whose name is Philip Logan. You're not supposed to tell me about nothing, because if you show me that you deleted it, it means it's still there. Because you're supposed to delete it and then show me that it's gone. That means you're supposed to hold out your empty hand and show me, say, not there. So that's why we say no content. So whatever it is you're trying to do, it do, and there's nothing more for me to say. There's no say it do.
So we do the delete response, and someone or whatever you know, like this one says 100% delete. This is similar to the no content thing.
The thing is, with a logical delete, you could send back a no content as well, because you don't want the person to know that you didn't delete it. You want them to think that you did. So you delete it, or you delete it, and then hold out the empty hand to show that nothing is there. Yeah? Exactly, yeah. Hold it behind you. Yeah. So yeah.
So,
Yeah.
delete. So we have a body. So we have first and last name. And we put delete and configure now with delete first name. Shouldn't you reply with the last name, which is left of the body?
I understand why you said that. And again, it is entirely dependent on how you write the code. Yeah. More than likely, I'll be able to show you some examples of what I mean by that tomorrow, in tomorrow's class. If we have class tomorrow, if not tomorrow, Friday, depending on where we have class. But yeah, so that's 204. Yeah, that's it for the 200s. Those are the important ones that we need to know for the 200s. Similar to the 100s, the 300s which I skipped, we're not really going to be looking too much at that. They're important, but not really for us to know. Because 300, anything that starts with a 300 usually mean the thing that you're trying to get access to, it's not here. It's actually over there. So it's not to say it don't exist. It exists. And maybe it's a case where you were told at some point that it's here. But I'm telling you now that if you want to get it, it's actually over there. And depending on the type of 300 requests, it could be a case where I'm telling you it's not here anymore, it's over there, and that's it. Or it could be a case where it's not here anymore, it's over there, let me take you there.
Redirect.
A redirect, yes. So redirects can communicate in the form of me just telling you where the new location is. And sometimes it can come in the form of me telling you where the new location is, and I also take you there. Yeah? So the 300 requests are typically redirect related. All right. But we don't really need those so much. 400s, those are important. 400 typically mean something went wrong. And when I say something went wrong, it can be one of two reasons. It can be because you as the client do something wrong, or it could be as me as the server do something wrong. Anything that starts with a 4 means you did something wrong. You being the client, you made a mistake. You want to, for example, top up your phone with some credit. You want to put credit on your phone. The My Digital app allows you to punch in the voucher into the app, and you press send, and it will add the information to, it will add the credit to your phone. The voucher might be 1, 2, 3, 4, 5, 6, 7, 8, so on, so on, so, right? But suppose when you type in the voucher number, you type in banana. That's not a valid voucher. So before it even tries to put the credit on your phone, it's going to read the number and see if it is a valid code. It might do something like, it might check to see if it is it's digits only. If it's 16 characters long, before it even checks to see if it's a valid code. So the fact that you did not type in numbers, the fact that you type in banana, that means that you did something wrong. So it's not even to say, I could not find this code in our voucher database. This couldn't be in the voucher database because it can't start with a B, right? So it will respond before any kind of processing and tell you, this is not a valid voucher, you do something wrong, come again. So 400 mean bad request. The request that you tried to make, it is invalid, you need to come again. Something wrong with it. Yeah? If it's a case where, for example, you're trying to log into a website and it asks you for your email address, and you type in an email address that don't have the @gmail.com, you just put in, you know, whatever the first part is, Philip.logan, and you press enter, they're going to say, no, this is not an email address because where's the @ua.edu.jm? This is a bad request. You do something wrong. If it's a case where you're trying to enter a website and it asks you for your age, and you type in Jim, that's not an age. Jim is not an age. You do something wrong. So it can tell you 400 bad requests.
So information is sent to the server and the
Yes.
server tells us about it.
Correct. It's a malformed request. Something wrong with it. You do something wrong. Yeah?
Question.
Yes.
What if I don't want to show, because even a while ago when somebody that type on YouTube and show it say 404. So I don't want to show the 404, I just want to tell you say it's a bad request.
Well, that's similar to what YouTube did a while ago, actually. So when I went onto YouTube, there's no 404 on this page. It just tells me what it wants me to see. I had to go into the settings in the browser to see what the response from the server was. And that's where I saw the 404. I pressed F12 on the keyboard. F12. F12 on the keyboard. And then I go to the network tab. When you go to the network tab, you see all the requests that go in and out of your browser. So I clicked on this to see what the response of my request was. This is the URL. It's a GET request, 404. And this is the request, and here's the response. The response is the website. Basically, oops, hold on. Network. And all this text here is everything that makes up the website. Actually, this is kind of short. I was expecting more. Oh, no, it makes sense.
That not export
It is exposed.
But why design where HTML are exposed?
HTML is not hidden. Because look at this. This is the web page. This is the code for the web page. This is part of the code for the web page, the part that you can see. There are parts of it like that determine the functionality. That part you don't see, because that's on the server, the back end. The front end, that's free. Anybody can see that.
YouTube itself.
Yeah. Let me pull up Wikipedia. So let me show you. I pull up Wikipedia. Is this text? No. All right, hold on. IoT Wikipedia. Internet of Things. If I click this, inspect, I can change this to Internet of Philip. I just changed it.
It's changed on your.
It changed on my computer. No, it don't change for you. It only changed for me. If I refresh, it goes right back. Internet of Things. Yeah, you can. You absolutely could. Yeah. Yeah, you could screenshot some. My brother did that to me a few years ago. You guys know Key and Peele, right?
Yeah.
There was a video where Key and Peele was doing a video where they were talking French, but it wasn't really French. A person in the comments was like, I'm French, I can verify this is not French. And I'm like, what gives this guy the authority to say that this is not French? And my brother changed the website to make it say, the President of France. And then he put the comment, and I'm like, oh, he's the President of France. He must know what I'm talking about. He must know. So,
Instagram, they load Instagram on your laptop browser.
maybe.
You can supposed to change sometimes.
Yeah. As long as you have access to it in this year, you can change anything. Yeah. Let me see, as long as you can, like you could change this picture too. Because this picture, the link is here. So you could just change the link with a different link. You can change it. But you know, the changes only last as long as you refresh. And when you refresh, it goes right back. Because when you refresh, that's you making a new request to the server to get the information. So it just goes back to the website and get back the original information and override what the changes you made. Yeah? Obviously, I'm showing you guys this for educational purposes and nothing else. Yeah? Okay.
We can produce 2 status codes, right?
I've never seen that. I don't think so.
When you did that type in the garbage with YouTube, it's a 404, but at the same time it redirected to YouTube.
I mean, I was already on YouTube. So, go back to YouTube. So I'm making this request to youtube.com. So I'm on YouTube. It's just that YouTube has to be the one to tell me that this thing don't exist. Because I'm asking YouTube for this. And YouTube looks at the request and it looks for this thing and it says, can't find it. So YouTube is telling me that this thing that I'm trying to find, it don't exist.
So if you put 1, 2, 3, 4 behind the YouTube, it's supposed to search something when you 1, 2, 3, 4 on YouTube.
You mean like if I put 1, 2, 3, 4 here?
Yeah. It's supposed to
Oh, whoa. Okay, that exists. Okay, so yeah, that exists. There's a user with the name 1234. It exists. Yeah? So you found it. That's crazy. But yeah, so YouTube is the one telling me that either it don't exist or here's the person you're looking for. Yeah? And yes, so going back to the 400s. 400 mean whatever it is you're trying to do, you did it wrong, come again. 401 means unauthorized. That means, typically what it means is, if it is a case where you're trying to get access to like a user profile that actually requires you to log in before you can see it, if you don't log in, they're going to tell you can't look at this, you can't see this, me can't get this. So you're trying to go on Philip Logan's Instagram, but you're not logged into Instagram and it's not a public account, you can't see it, you're unauthorized. So I will not show you, because you can't see it. Log in and come back again. Yeah? So that's 401. 403 now.
Go This is something about expired sessions. So say for example, on the apps where it take too long to do it, show that this is what come up.
Yeah. So it might be a case where your login session is timed. You're only logged in as long as you're using the app actively. If it's a case where you put on your phone and you just make it go on, sit down, and you make half hour pass, they're going to say, oh, you're not using the website anymore. Let me log you out for security purposes.
Okay.
And then if you try to do something again, it will say you're logged out, say 401. You have to log in again and come back. 403, similar but different. 403 means maybe you are logged in, but the thing that you're trying to access, you don't have clearance to access it. This is some Area 51 type stuff. Yeah? You can't access this. So it might be a case where, yes, you are logged in into VLE, and if you want to get a full list of the students registered for a course, no, me can't show you that. You're not a lecturer. Because I know that you're logged in as Tyree Thorpe, right? You're not Philip Logan, so me can't show you that. So this is forbidden information. So you are logged in, but me can't show you that because you're not Philip Logan. Yeah? Exactly. Right, so that's 403 forbidden. Yeah? We know this one already. 404 not found. It means you're trying to, for example, look for a user that has an ID of 9s. That don't exist because we all know that, it's supposed to be 620, blah, blah, blah. But if you're looking for a username with this, or a user with the ID that, it don't exist. So tell you, it don't exist. So those are the 400s. Those are the ones that are important. It is perfectly fine for your application to respond with a status code that starts with a 4, because that's you telling the user that they did something wrong. If it is a case where they did something wrong and the server get it and it don't know what to do with it, and it's frightened, and it just start crash out and it don't know what to do, then it might return, oh, forget about this one. Yeah, this is a teapot. This is a joke. I didn't make this joke. It's a real status code that exists, that a server can respond in, but it means I'm a teapot. It was created by the HTTP people as an April Fool's joke. So it's real, it's just useless. Unless you had a server that's supposed to can make tea and you ask it for coffee, but like, I can't make coffee, I'm a teapot. So it returned in 418. It's a real status code. It actually exists and it have documentation. But it's useless. Yeah, right. So I was saying, if you have an issue with something that the client did, and you as a server don't know how to handle it, and it makes the application crash or the server crash, you'll get back a 500. So what I'll say to my students is, if there's an error and it's the client's fault and you return a 400, that's fine. But if you return a 500, it means that you as a programmer need to fix your code. You should not intentionally send back a 500. Because if you send back a 500 as a response status code, it means that you're admitting that you did something wrong as a server. Or you could not handle the request that was coming in. Yeah? So if you're designing a calculator application and somebody put in 20 divided by 0, the server may crash if you try to divide it by 0. And if it does crash, it may return a 500. But what should happen is you should recognize that the person is trying to perform an illegal mathematical operation. So you should handle the error. So you should see the 0 and say, oh, you're trying to divide by 0? You can't do that. Return a 400 instead. Bad request. You cannot divide by 0. That's what you should do. Yeah? So if it's a case where you're writing your code and you're doing your testing, and you return, the server returns a 500, you know that your code is wrong and you need to go in and fix it. You have a bug that you need to fix. 503 means service unavailable. What this means is, it could be a case where you have, for example, your server that you're making a request to is dependent on the response of another server. So let's say, for instance, Digicel allows people to watch Netflix free. This is a horrible example. Because in my example, I'm going to say, if you get back a 503 from Digicel, it could mean that maybe Netflix is down. That's a horrible example, because why would Digicel be up and Netflix is down? It should be the opposite. Netflix can't go down. Because Netflix is Netflix. Big Netflix? A joke. Right? So it could be a case where maybe Digicel is allowing you on their website to access Netflix for free. But if, for example, Netflix is down, something is not wrong with Digicel server, but there is a server somewhere that is inaccessible. And because it's inaccessible, I can't show you Netflix. You didn't do anything wrong. You are valid if you want to watch Bridgerton, but I can't show you because Netflix is down. So 503. Right. And maybe the police lock down on the server and now it's not available anymore. So you're trying to access it, it's not there anymore. Get the 503. Yeah? And typical.
I guess this happened to Sastre already.
Oh, he said 502, right?
Yes, so
What 502 mean? We remember what 502 mean. But you can Google it.
there's some 503.
Maybe 503. If it was a 503, it could also mean that, you know, server maintenance, meaning they intentionally took the server down so that they could fix something and bring it back up. So they're typically temporary. It means that the server is inaccessible at the moment and I can't handle your request now. So it's typically temporary. It could be intentionally brought down, it could be unintentionally. Server downtime or temporary downtime because of overload or an attack or whatever it is. So some part of the server is up, but it can't service your request because some part is down.
And then the delay was to retry after is that you set that time frame.
Yeah, you would set that. Okay, I had some of those, but they're not terribly important, I guess. But yeah.
So meet a response of wall fixing the server.
Yes. Or yeah, if it's a mid server, yes.
It's engineering.
Well,
Not the part.
I don't know about that.
Because if you look at VLA setup, that setup aesthetically pleasing.
You don't think so? It's not MIT's design it. It's Moodle. It's a framework. It's something where you just get off the shelf and you modify.
I just modified.
So maybe it don't look good because the person that modified it never make it pretty. I don't know. But yeah. So yeah. Any questions? Okay with this?
It's good so far.
All right. You guys are registered for the course already?
We don't override.
Okay. All right, no problem. I think you should be able to talk to Dr. Faulkner for that. Yeah. So yeah, I will see if I can find out when we can have class again. And everybody in the WhatsApp group? Yeah. Okay. What's that?
So we can run online.
Yeah, I guess. Yeah. If we can't find a time, we can probably do online class. So yeah, we can stop there for today. And I'll let you know if we're going to have class tomorrow or Friday if we need to do it online. We'll talk about it in the group.
Sir,
Yeah.
especially